Hi everyone. In this lecture series, we are going to see about the A to D and D to A converters. In most of the cases, in peripheral interface that is used for interfacing the analog to digital converters with the microprocessor. We have already studied how the 8255 interfaced with 8086 as an IO port in the previous video. The function in this section we are going to emphasize only the interfacing techniques of the analog to the digital converters. The analog to digital converters is treated as an input device by the microprocessor that sends an initializing signal to the ADC to start the analog to digital data conversion process. The start of conversion signal is a pulse of a specific duration. So here we are going to see the A to D. The process of A to D conversion is a slow process, and the microprocessor has to wait for the digital data till the conversion is over. Once the conversion is over, the ADC sends end of conversion, that is EOC signal, to inform the microprocessor that the conversion is over and the result is ready at the output buffer of the ADC. These tasks of issuing an SOC pulse to ADC, reading end of conversion from the ADC and reading the digital output of the ADC, that will be carried out by the ports. Here, what is the time taken by the ADC from an active edge of the SOC pulse till the active edge of the signal, that is termed to be as the conversion delay of the ADC. It may range anywhere from the microseconds in case of fast ADC to even a few hundred milliseconds in case of slow ADCs. We are having both fast as well as the slow. Here, the ADC that has been available in the market uses different conversion techniques for the conversion of analog signal to the digital signal, and they will provide the success approximation techniques and the dual slope integration techniques are the most popular techniques that has been used in the integrated ADC chip. Here, the general algorithm for ADC interfacing contains the following steps. So, what are all the steps that has been involved means? The first one is we have to ensure the stability of analog input that is applied to the ADC, issue start of conversion pulse to ADC, read end of conversion signal to mark the end of conversion process, and the last one is we are going to read the digital data output of the analog to digital converter as the equivalent digital output. Analog input voltage must be constant at the input of the ADC from the start of the conversion to till the end of the conversion. We are going to get the correct results, and at the same time this may be ensured by a sample and hold circuit which samples the analog signal, and it is constant for a specific time duration. The microprocessor may issue a hold signal to that of the sample and hold circuit. If the applied input changes before the complete conversion process is over, the digital equivalent of the analog input calculated by the ADC, it may not be correct. Here we are having some of the pins. What we are mentioning in the ADC is 0808 or 0809. So here we are having the successive approximation converters, and this techniques is one of the fast techniques for the A to D conversion. The conversion delay is 100 microsecond at a clock frequency, and it is quite as possible compared to the other converters. These converters do not need any external zero or the full scale adjustments. Using the address inputs, multi-channel acquisition system can be designed using a single ADC. The CPU may drive these lines using output port lines, and in case of the multi-channel applications, if one needs a sample and hold circuit for the conversion of fast signal into equivalent digital quantities, we are having some of the supply pins, ground pins, reference voltage positive, that is plus 5 volt maximum, 0 volt will be minimum. So this is the diagram of the A to D converter. Here we are interfacing 8255 with the the ADC 0808. We are having the data bus buffer, read write logic. Apart from that, we are having the port address in the 8255. Just we are going to interface with the address slash enable and the ground signal that has been given in the ADC in order to get grounded. So IP0 to IP7, we are having the analog inputs, and ABC, that is address lines for selecting the analog inputs. After that, EOC, it is nothing that the end of conversion, SOC start of conversion. If the output latch enable pin, if it is high, it enables the output pin, and the last one is for the ADC pin. So these are all the ports pin available for this A to D converter. Thank you.